This one, I was very pleased. Like I say, one mystery that I couldn't understand for more than a year of studying this stuff is how it ever learned what all the words mean and put them in some order so similar meaning words are near each other, and the distance between words actually maps to the actual meaning difference between words. And now this is how it works. That's done by tokenization. So you have a sentence here: Napoleon revolutionized military organization. A CLS is a marker saying we're about to start a sentence. It encodes them into numbers, and then it embeds them as like high order vectors in some like high dimensional space. So we're going to tokenize the sentences. We're using the BERT tokenizer. BERT is a bidirectional encoder. It's a very powerful language encoder used by a lot of these. So if you do that, it's going to take Napoleon revolutionized military organization. Napoleon has legacy. Legacy still lives. Those are 3 sentences it has. It's going to tokenize them. And so you can see Napoleon is 8891. And when you refer to Napoleon again, it's still 8891. A period is 1012 every time. 101 is the start mark. 102 is the end mark. And you notice it takes revolutionized and breaks it into 2 things, because ized is like a modifier. So this is what it actually does to turn these words into numbers. Now these numbers are not yet in a logical order where the numbers that are near each other are near in meaning. They're just numbers. All right, then to learn what words are associated with other words, we mask it. So here it's going to mask 15% of the tokens randomly, and it's going to change some of them. So here you see these have been changed to 103. 103 is the mask. So these 3 things are missing. They have been masked. And now you train your model to guess the masked word from the words around it, and therefore it learns what words should be near each other. And that's the game. And so you can predict a masked word here. And here it'll show you so this is the one I showed you before. Artificial intelligence can take over the world, will take over the world, to take over the world. Intelligence says take over the world. Various ways to complete that sentence. And here's the score. The score is basically the percentage of chance that that's it. 30% chance of this, 18% of that, 5% of that, and so on. Basically, how many times in the training data was this word found in that sentence or a sentence like it? So then you do sequencing sentences, sentence A and sentence B, where sentence B is either the right sentence or a random wrong sentence, and it learns to match them. And you can do that one too and see how it goes. And then you can test it by doing a language comprehension task, classification. Here you get movie reviews. There are 50,000 movie reviews out there, and they have the movie review in text. And then they have how many stars that movie gets from like 1 to 5. And here we're going to just set them into positive and negative. So you download this database of movie reviews, and we're going to determine the sentiment, which is it approval for this movie or disapproval? And so here's the review, here's the sentiment. And so we do sentiment analysis with BERT. You just download BERT. So it only takes a few lines of Python to do it. And now there's a pre-trained BERT model for this task. Remember, training a model is a huge task that takes a lot of time, a lot of GPUs, and a lot of money. So I'm not training a model. I'm downloading a pre-trained model. They've trained a model, but it was trained to give it a number of stars from 1 to 5. So here's the reviews, the first few words of the review, and then the sentiment, 2, 5, 1, 4, and so on. So 1 is a bad movie, 5 is a good movie. All right. And so now to evaluate the model's accuracy, I just say, I'm going to call them wrong if it's a positive review, but sentiment is 1 or 2, or negative and 4 and 5. 3, I'm not going to count as wrong at any time. That's in the middle. Just when I evaluate how many of them are wrong. And here I got 6 wrong out of 100 movies. So movies it's never hit, pretty good. It can categorize them. And so that's how effective it is at the end. So that's what I wanted to show you. This is what's at the heart of all language models. This is how this is the sense in which it understands language. It mathematically knows what words will be found near other words and what words should be in the next sentence to match this sentence. That's all. It doesn't have any idea what any of the words mean, or whether what it's saying is true or false, or whether it's a fantasy story or a lie. That's what you get. That's what's fooling people into thinking it's intelligent. It's writing English that looks pretty good, but it doesn't have any idea what it's saying. So that's it for this one.